Okay, in this video, we will talk about secular equations and secular determinants in more generalized terms. നമ്മൾ കഴിഞ്ഞ ക്ലാസ്സിൽ വേരിയേഷൻ തിയറം ലീനിയർ വേരിയേഷൻ ഫങ്ഷൻസ് പഠിച്ചുകൊണ്ടിരുന്നപ്പോൾ we finally ended up in a set of equations called as secular equations. നമ്മൾ ആ കേസിൽ അസ്യൂം ചെയ്ത ട്രയൽ ഫംഗ്ഷൻ എന്ന് പറയുന്നത് psi is equal to a1 അല്ലെങ്കിൽ lambda 1 phi 1, that is lambda 1 phi 1 plus lambda 2 phi 2. This was our trial function that we used for the variation treatment. Okay, and here lambda 1 and lambda 2 were the variable parameters, and with this we calculated the expectation value of energy E bar, and this expectation value E bar was minimized with respect to lambda 1 and lambda 2, so that dou E bar by dou lambda 1 is equal to dou E bar by dou lambda 2, that is equal to 0. When we did this procedure, we reached a set of equations, and what were those set of equations? That is lambda 1 into h11 minus E bar s11 plus lambda 2 into h12 minus E bar s12, that is equal to 0, and lambda 1 into h21 minus E bar s21 plus lambda 2 into h22 minus E bar s22 is equal to 0, and these equations were called as secular equations. Okay, and there was a determinant corresponding to the coefficient of the variable parameters, and that determinant was determinant h11 minus E bar s11 and h12 minus E bar s12, then h21 minus E bar s21, h22 minus E bar s22, and determinant was equal to 0, and this determinant is called as secular determinant. Okay, secular determinant. And this is what we learned in the last class. Then we saw that the root of this secular determinants means this is a second order secular determinant, therefore there will be two roots for E bar, that is E1 and E2, and the lower value of this E bar will give the energy of the system, means the energy corresponding to the trial wave function. Obviously that energy will be greater than the true ground state energy of the system. That is what the variation theorem states, right? So in this video, what I am going to talk about, what I am going to discuss is we are going to construct a set of secular equations and secular determinants, but more generalized. Okay, we are not going to restrict our psi function as a two-term psi function. Instead, we are going to construct a psi function with more terms, and constructing such a psi function will be more accurate. Okay, so let us construct another psi function, that is psi is equal to, or trial function psi is equal to lambda 1 phi 1 plus lambda 2 phi 2 plus lambda 3 phi 3 plus etc. Okay, this is our trial function. Okay, and then it will go up to the nth term. Okay, and the last term is lambda plus lambda n phi n. Okay, so this is our psi function. So this is a trial function containing n terms, not only two terms, n terms. So that is a generalized idea that we have adopted here. Okay, and if we are doing the similar procedure, means if we are calculating the expectation value E bar with this trial function, and minimizing this expectation value with respect to each of the variable parameters like lambda 1, dou lambda 1, that is equal to dou E bar by dou lambda 2, that is equal to dou E bar by dou lambda 3, that is equal to etc. is equal to dou E bar divided by dou lambda n, that is equal to 0. We are doing the minimization of E bar with respect to all the n variable parameters. And this will lead to n secular equation. You know that when we were doing with the two of the variable parameters, a trial function containing two terms, that led to two of the secular equations. Okay. And if the trial function contains n terms, then we will end up in n secular equations. What are those secular equations? It is very easy to write those secular equations. That is lambda 1 into h11 minus E bar s11 plus lambda 2 into h12. The first number here shows the row and second one shows the column. Okay, so the first row, second column. Here first row, first column. Here first row, second column. So means when we are making the determinant out of this, it will be like that. Okay, so lambda 2 h12 minus E bar s12 plus lambda 3 h13 minus E bar s13 plus etc. The last term will be lambda n h1n minus E bar s1n. Okay, so that is the last term and that is equal to 0. Okay, so that is an equation. And similarly, we will get another equation, that is lambda 1 into, here we have to be careful, that is second row. So this number is 2. First column, then it will be 1. So h21 minus E bar s21 plus lambda 2 into h22 minus E bar s22 plus lambda 3 into h23 minus E bar s23 plus etc. plus lambda n into that is 2n minus E bar s2n is equal to 0. That is another equation. Similarly, we will get n equations. So we can write etc. etc. And the last equation is the nth equation. That nth equation will be lambda 1 into h, that is the nth row. So first number should be n, first column n1. So hn1 minus E bar sn1 plus lambda 2 into hn2 minus E bar sn2 plus lambda 3 into then n3 minus E bar sn3 plus etc. plus lambda n, that is nth row and nth column, that is lambda nn nn minus E bar snn, that is equal to 0. So we get n equations, and these n equations are called n secular equations. Okay, so these are n secular equations. Secular equations. Okay, so we have n secular equations in this case because our trial function is a linear combination of n functions. So we get n secular equations. Corresponding to get, we will get a determinant, and that will be an nth order secular determinant. What will be that determinant? The determinant will be determinant h11 minus E bar s11, then h12 minus E bar s12 then H13 minus E bar S13 etc. And the last term is H1n minus E bar S1n. Okay. Then the second row of the determinant, that is H21 minus E bar S21. Then H22 minus E bar S22. Then H23 minus E bar S23 etc. The last term is H2n minus E bar S2n. Okay, H2n minus E bar S2n. And if you are going for the third row, then it will be H31 minus E bar S31, H32 minus E bar S32, then H33 minus E bar S33 etc. to H3n minus E bar S3n etc. Okay, then we will go for the last row of this determinant. Last row is the nth row. So that is Hn1 minus E bar Sn1, then Hn2 minus E bar Sn2, then Hn3 minus E bar Sn3 etc. to Hn minus E bar Sn. Okay, so this is a determinant having n rows and n columns. Okay, so that is equal to 0, and this determinant is called a secular determinant. Secular determinant. Okay, so now you know how the secular equations and secular determinants will appear. And if you go for the solution of this secular determinant, then you will get n values of E bar. Means since this is a nth order secular determinant, you will get n roots. Means you will get E1, E2, E3 etc. to En as the roots of the secular determinant. Okay, and you will choose the lowest value as the energy corresponding to the trial wave function. Okay, now I hope you got an idea about the secular determinants and secular equations and secular determinant. We already discussed this in our previous class, but here I have given you a more generalized version of the secular equations and secular determinants. If you have any doubt, please don't hesitate to ask me. Thank you for watching and stay tuned.